Okay, here we go. So to see if this number is divisible by 18, because we don't know the rules, the divisibility rules for 18, we can write 18 as 2 times 9, or another way of saying 18 is 3 times 6. So one way is to check with these two numbers. Is 78,280 divisible by 2? Yes, it is, because it's an even number. Is it divisible by 9? Let's add all the numbers. 7 and 8 is 15, plus these 2 is 10, it's 25. Is 25 divisible by 9? No, so it didn't work for 2 and 9, so that means that it's not going to work for 18. If you use 3 and 6, the same thing. Is it divisible by 3? 7, 8 is 25. That's 10, 25. Already it's not divisible by 3, so I don't even have to worry about, with the divisibility rule of 6. Okay, it doesn't work. It has to work for both. So if it's already not working for the first one, the first factor, I know that that's not going to work. Okay, so that all should be written in a sentence. Okay, so you can either have chosen 2 and 9, 3 and 6. Make sure you explain it. And I know now that when I'm going to do this particular division, I'm going to get a remainder. Okay, because it's not going to work out all pretty. Divided by 18, it's 4. No, yeah, 4 goes. 4 times 8 is 2. Carry the 3, 7, 6. Bring the 2 down. 3. The 3 works, which is 54. 12, 8, 8, and this is going to be 4, 72. This is going to be 16, 0, and that looks like an 8. 64, no, it's going to be a 7. 7 times 8 is 56, goes 5, 126. No, it could be an 8. 64, yeah, sorry, that could be an 8. 8 times 8 is 64. 8 times 8 is 8, and this is 144. Good, and I have 16 left over. So it's going to be 4,348 with a remainder of 16. But we already knew there was going to be a remainder. Okay, so my answer here, knowing that it wasn't divisible by 18, tells me that when I divided this, I should have expected a remainder. Move on. Find the prime factorization. Okay, so pick whatever number you're comfortable with. This is divisible by 3, because if I add, it equals to 9. Divisible by 5. Okay, so either way, you can pick. Pick whichever one you like. I'm going to pick 3. 3 times something is 350, and I have no idea what that is, so I'm going to take that. A couple of seconds here. 3 goes in 3 one time. Bring the 1. 3 goes to 1 0 times. Bring the 5 down. 3 goes into 15 5 times. So it's going to be 3 and 105. I circle this to let me know it's a prime number, and I don't have to worry about it anymore. 105, I'm going to choose 5, and it's going to be 21. Circle again, prime number. 21 is 3 and 7. Circle, circle. I'm done. Let's put this in order. It's 3 times another 3 times a 5 and times a 7. Please don't leave it like that, because it's asking you to write in exponential form. So it's going to be 3 to the second power times 5 times 7. Final answer. This one, you can sit and guess to see what number goes in there. But a key here would be that it says prime factor, so I know this number has to be a prime number, the missing number. So you got 5, 7, 9, could be another 3. Or you can just go and do this. 168 split up into 10. 10 is 2 and 5. 168 I'm going to split up into 2, and that's going to be 84. 84, yeah, 84 works. 84 is going to be 2 again for me. 2 and 42. 42 be 6 and 7. Circle, and 6 is 2 and 3. So this one's a large one. So it's 2, 2, 2. There's 4 2s, so 2 to the 4th. So far, so good. Times 3 times this 5 times the 7. So my missing number was a 5. Okay. And medium-sized truck can hold 85 moving boxes. How many trips it will take the truck? So you can do this several ways. What did I just do? And one of the ways you can do it is by using division. Okay. One trip can take 85 boxes, so you can do addition if you want, but that's just going to take a long time. So 2 trips would take 170 boxes, 3 trips would take 255 boxes, and go so on and so on, so forth and so forth, I should say. But that's going to take you a long time. Or you can just do division. So let's attack that. 134. How many times can 85 go in that? Not into 1, not into 0, but into 3 one time. Subtract, a little boring happening here. 13 minus 5 is 8. 9 minus 8 is 1. And bring the 4 down. 85 goes into 184 2 times. 170, 14 left over. So, what does this mean? I can make 12 trips. And every single trip here will have 85 boxes. And then when I come back, I'm only going to have 14 boxes left over in my facility to take. Well, I can't leave it there. I still need to take that extra trip, right? I'm taking all these boxes. So 12 trips will have my truck packed, and 1 trip will have my truck with 14 boxes. So not 12 trips, but instead I need to make 13 trips because I gotta take everything. Okay? This one. Book of stamps have 20 stamps. Envelopes counting 12. What's the least amount that Tina needs to buy? So you have 1 stamp for every 1 envelope. Okay, so remember that little video you saw? It's like 1 hot dog bun for every hot dog. It's the same idea. Okay, so this is an LCM problem. Let's use the ladder method. And 4 goes 12 3 times, goes for 25 times. So there you go. My LCM is going to be the product of all these 3 numbers. 4 times 3 times 5, which is going to give me, I don't know, 60. Sounds like a nice number. So, what does that mean? That I need to buy 60 books of stamps or 60 boxes of envelopes? No, I need a total of 60 individual stamps, 60 individual envelopes. So what do I need to do to get 60 of each? Well, I need to buy, well, stamps comes in 20s, right? So 60, I need 16 total. Divided by 20 means, let me write stamps here, means I need to buy 3 books of stamps. Right? So I have 3 books of stamps. And envelopes, they come in boxes of 12. So I need a total of 60. If I divide it by 12, I get 5 boxes of envelopes. Okay, and that's what I need to buy. So I need a total of 60 each, but then I need, 3 books of stamps and 5 boxes of envelopes. Round time, it's 10:52. Okay. 6, Delta airplane leaves JFK every 9 minutes, so I'm gonna make the right Delta LaGuardia, sorry, LaGuardia. And this is another JetBlue JFK every 9 minutes. If it's 12:09 p.m., both planes just left. When will just left together? When will both airlines have a plane leave at the same? So it was 12:09 right now, and 12:09 here, 12:09, and 1 airplane from each side, from each airport, just left together at the same time from different airports, of course. When will that happen again? When, you have 1 from each airline leave at the same time from different airports. Well, we can do it this way. LaGuardia is every 9 minutes. Another Delta airplane will fly out, 12:18. Another 9 minutes will be 12:27. Another 19 will be 12:36, and so forth. JetBlue is every 17, so 12 plus 17 minutes will be, 17:26. Another 17 minutes will be 43. You can go on and on and on, and eventually, at a certain down the line, you will find a time that's equal on both airports, which means an airplane just left again together at the same time. And that could be tedious and long, or you can find the LCM. Again, this is a problem. It's something that's repeating over and over, and you want to see when they meet down the line. So let's just do the LCM. So ladder method, 1 is the only number that goes into all 3, so you know that you have to multiply these 3. So the LCM is the product of all these 3. So 9 times 17, I have no idea. 3, carry the 6, right? 9 times 15. 153 minutes later, an airplane from Delta will leave LaGuardia, and an airplane for JFK, from JetBlue will leave JFK at exactly the same time. So what's 153 minutes? Well, let's change that to hours. 1 hour is 60. Okay. 2 hours is 120. 3 hours is 180. So it's definitely between 2 hours and 3 hours. So it's not 3 hours. It's 120. Definitely 2 hours, right? So if I subtract, I get 33 minutes left over, right? So I know it's 2 hours for sure because that takes care of 120 minutes. It's 2 hours for sure and 33 minutes. Not bad. So what's the time right now? 12:09 p.m. If you're familiar with military time, that's pretty easy. 12 plus 2. We're going to add the minutes over here. This one is nice. 42. And then the hours I can add is 14. So it's 1400 hours and 42 minutes, or in the other way, non-military time, it's 2:42 p.m. Either or, same thing. Okay. Okay, there's a concert. There's 24 wooden chairs, 30 plastic chairs, and he wants to make the largest number of equal rows. So rows of wooden chairs. All right, wooden over here. Rows of plastic chairs. That's what he wants to make. All plastic chairs, I guess. Aesthetically, he just wants to make it pretty. And what do we want? He wants to make the largest possible number of rows, and so that every row has the same amount. So if there's, I'm making this up right now, 7 chairs, 7 chairs, 7 chairs, 7 chairs. This would be 7 chairs, 7 chairs, 7 chairs, 7 chairs, 7 chairs. Okay, so you have to have the same amount of chairs in each row. So the number of rows might be different. Okay, so there might be more plastic rows, but the numbers of chairs have to be the same. Okay, so let's tackle this. This is a equal rows. There's your key here. I would definitely look at that, or largest too. So that tells you it's a GCF problem. Why am I doing that? So 24 and 30, GCF. 2 goes, 3 goes, 4 goes, 5 goes, 6 also goes, right? So let's use the biggest number. 6 goes to 24 4 times. 6 going to 30, I don't know, 5 times. So here's a GCF. What does it mean? Okay, here's what. So 6 is the greatest number. Okay. Oops, hang on a second. So that's greatest number of chairs you can put in. All right. So let's do the wooden chairs. Wooden chairs. It's 24. So if 6 is the biggest number of chairs you can put in every single row, how many rows can we have? We have a total of 24. 24 divided by 6 is 4. So I'm going to make 1 row, 2 rows, 3 rows, 4 rows. 6 wooden chairs, 6 wooden chairs, 6 wooden chairs, 6 wooden chairs. Good. That's 24. Plastic. How many chairs do I have? 30. So 30 again. And I'm going to put 6 chairs in each row. It's going to give me 5. 1, 2, 3, 4, 5. 6 plastic chairs. 6, 6, 6, and 6. Each row has 6 plastic chairs. Good. Did we answer all the questions? No, we didn't. How many rows of only wooden chairs will he have? Well, there's 1 row, 2 rows, 3 rows, 4 rows. This particular answer, there will be 4 rows of wooden chairs. Please write the answer as a sentence. Okie dokie. 8. Kate and Lydia each picked flowers in the meadow. Kate picked 42 red flowers. Lydia picked 56 blue flowers. Oh, I like blue flowers. The girls are going to divide each group of flowers evenly among vases. What is the greatest number of vases they can fill? And how many red flowers will go in each vase? So here's a vase, right? And you want to put some red flowers in here. And you want to put some blue flowers to make it pretty. Okay, and then you're going to take another vase, do the same. Some red flowers in here, some blue flowers in here. So we want to make the greatest number of vases. What's the biggest number of vases that we can do so that every vase has the same amount of red, same amount of blue? Let's figure that out. So obviously here gives you hints. Okay, we're going to divide. That's another hint. GCF, 42 and 56. Let's start with 2. 21 and 28. 2 is not going to work anymore. 3 is not going to work. 4, 5, 6, 7. 7 goes 21 3 times, and 4 that many times. What is this 42? 42 was a number of red, and this one was obviously blue. So GCF equals the product of 2 and 7. 2 times 7, it's going to give us 14. So now we know we can make 14 vases. Will I make 14 vases? Right, I'm going to make it like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 very ugly vases. And in each vase, so what's the greatest number of vases they can fill? So the first answer would be 14 vases. And how many red flowers will go in each place? So I know there's 14. How many red flowers do we have? 42. 42 divided by 14 equals 3. So it's going to be 3 red flowers. I'm going to write 3R. 3 red, 3 red, 3 red. And I'm not going to do this for all the vases, but you get the point. Every vase will have 3 flowers. And I know the question didn't say, but how many blue will go in it? Well, you have 56 blue flowers, and you're going to divide that by 14 vases, and you're going to end up putting 4 blue. So 3 red, 4 blue, 3 red, 4 blue, 3 red, 4 blue. You're going to get a nice little pretty vase on all 14. Okay? And that's the word I'm looking for. Howard, selling comic book collections. Oh, I had one. Just sad that I left it all in Brazil. Okay, so he has 96 Superman comic books and 72 Batman. He wants to separate them in equal bags, with each bag having the same comic book title. So he puts the greatest number of comics in each bag. How many bags will only have Batman comic books? So greatest, separate. Okay, hint, GCF. So let's go 96, 72. This is Superman and this is Batman. 2 works. 48, 36. 2 works again, but I don't want to use it, so I'm going to use 4. 4 is 12, 3. I can use 3, 4, and 1. Done. There's shorter ways of doing it, so I'm just 2 times 4 times 3 is your GCF. 2 times GCF is your 2 times 4 times 3, which is 824. Did I do something wrong here? 4 goes 48 3 times. Oh, yes, I did. We're gonna start again because I did. That didn't make sense. So 96, 72. Let's use 2, 48, 36. I'm gonna use 2 again. 24 and 18. There was this mistake, and we're gonna use a bigger number. 6 is 4 and 3. Good. I'm happy with this. So the GCF is the product of all these 3 numbers, 2 times 2 times 6, which is 24. Okay, so that's the greatest number of comics he can put in each bag. So let's start with the Superman. Superman comic books, he has 96, right? So, and he wants to put them in bags. There are bags. I don't know how many, but he wants to put them in bags. It's only Superman titles in each bag. So how many can you put in each bag? 24. So let's divide that. So if I have 96 and I divide it by 4, that's going to be 4. I can make 4 bags of Superman comic books. 24 comic books here. 24, 24, 24. Good. And Batman. He has how many? 72. Well, it's going to divide that by 24, right? And then we're going to get times, that equals 3. So 1 bag of 24 comic books, Batman. Another bag of 24 comic books, Batman. And another bag of 24 comic books, Batman. What's the question? How many bags will only have comic books? Well, 1 bag, 2 bags, 3 bags. So my answer is 3 bags will only have Batman comic books. Okay, so all these things here help me visualize it. The little bags, the little pictures, how many go in each bag. Okay, so again, it's a tool that you may want to use. Oh, I keep forgetting. I'm going to tell you what your bonus word is. Bonus word is going to be this, which was our score in our soccer game on Friday. Okay, for the record, we scored this much. Okay, so there's your bonus word. Use the distributive property to create an equivalent expression. Okay, so distributive property, the little bird attacking the pigs inside. Okay, and we're going to rewrite this as 8 attacking the 12 using multiplication. Forget the plus sign. 8 attacking the 9. And we're just going to make that a little bit prettier. 8 times 12 is 96 plus 8 times 9 is 72. And that's what I'm looking for. Okay, if I had that set, evaluate all the way to the end, then you can add these two numbers and give me one single answer, but I just wanted this. Okay, so for now I'm looking to see if you know how to apply the distributive property, where you get the term outside multiplying every term inside the parentheses by that number. Okay. Use the distributive property to create an equivalent. Again, we're doing the same thing. So 7 times 11, I'll write it right here, plus 7 times 6, plus 7 times 28, and nope, not 28, 7 times 4, 77, plus 42, plus 28. Okay, so again, that's what I want. So this expression and this expression on top, they're equivalent because they mean the same thing. So use the GCF to rewrite the expression as a product of GCF and two numbers. Very fancy word of saying, let's find this. Okay, so I want to take the GCF, find the GCF, right, which is the number outside, and find what the other two numbers are, sum multiplied by the sum of two other numbers. Okay, so I need to find the GCF first between 27 and 63. You can use the ladder method. 2, no. 3, yes, actually 3 does. 3 goes 27 9 times. 3 goes 63 21 times. Can we continue? Yes, we can. 3 and 9 3 times. 3 and 21 7 times. Are we done? Yep. So the GCF is a product of those two numbers, which is 3 times 3 gives you 9. So 9 is the biggest factor that 27 63 share. 9 goes 27. 9 goes also in 2063. And so 9 times what's 27 is 3. 9 times what's 63, and it's 7. You can always double check using the distributive property again. Okay. There's no way really you can get this particular question wrong because you can always check. All right. Or hey, look. There's your numbers inside, okay? But that's your answer. Same thing here. The GCF, right? Minus in this case. So we write the expression as a product, something. The GCF multiplying. Oh, this should have said difference, by the way, not sum. Difference of two numbers. 84 and 48. So I'm gonna use 2. 42 and 24. I can use 2 again. 21 and 8. Yes. That it? 2, no. 3, no. 4, no. I think that's it. I was expecting something a little bigger. So GCF is 4. So 4 goes outside. That's our GCF. 4 times what is 84? Here's our answer. That's why the ladder method comes in nicely. Or you can just figure it out. It's 21. And then 4 times what gives you 48? No. Okay, first of all, that's not an 8. That's a 12. See, that helps to check. So 4 times what is 48? It's 12. Had I just blindly written the 8 that was here, I would have gotten it wrong, because 4 times 8 is definitely not 48. So again, 4 times 21 gives you this 84. Good, check. 4 times 12, check, gives you that. Okay, so that's it. The other sheet I am not doing because that's a little simple. I will do spiral 2, but I'll put this up right away so you can get going. So if you have questions, let me know.